So friends, this is my code for finding the Fibonacci number. This is just the plain recursive code. I have not used dynamic programming anywhere in this particular code. So what I am doing is I am taking the number of test cases as my input, and I will run this loop according to the total number of test cases that user have given input to. And in this I am just taking the n as the nth Fibonacci number which I need to find out, and I am giving this particular value n to my fib function. What my fib function is doing is it's just plain recursive code, nothing else, no DP involved. It's just calculating the nth Fibonacci number using recursion. It is calculating the n minus 1 Fibonacci number, calculating the n minus 2 Fibonacci number, and just summing it up to get the nth Fibonacci number. So let's see how much time this particular code will take. So I will just compile this code. It is compiled. I now have to give the total number of test cases, let's say 10. Now what will be the fifth Fibonacci number? It gave 5. Yes, 5 is the fifth Fibonacci number. Let's say I need to calculate the 10th Fibonacci number. 55 is the 10th Fibonacci number. Now let's see what will be the 100th Fibonacci number. Now as we can see, it is taking a lot of time to calculate it. I will just control C it because it will take a lot of time, and just control C it. Now we have seen that to calculate the 100th Fibonacci number using this particular function, it will take a lot of time because there will be a lot of sub problems, and we haven't saved the result of those sub problems, and those sub problems are being overlapping, and because these problems are overlapping sub problems, they haven't been saved, and our code is just recalculating it again and again. So this will take a lot of time. Now this is my DP code for the same sub problem. What I have used is I have taken a DP table. LL means long. This is my 1D array. What I have done is I have a particular function named init. What init does is it initializes my DP table. So DP0, the 0th Fibonacci, I have initialized the 0th Fibonacci number as 0, the first Fibonacci number as 1, and from 2 to 200 I have initialized it with -1, because at this point of time I don't know what will be my second Fibonacci number, my third Fibonacci number, 100th Fibonacci number, I don't know. I just initialize it with -1. I will tell you why I will initialize it with -1. Now this is the same code. I have taken n as the nth Fibonacci number as my input. I have given n to my fib function. Now let's see what is happening in the fib function. This is the same code which I have used in the recursive the previous code. Now I am checking whether dp of n minus 1. Now dp of what does dp n minus 1 signifies? It signifies that whether I have calculated dp n minus 1 signifies that the nth Fibonacci, n minus first Fibonacci number. What dp n minus 2 signifies? It is the n minus second Fibonacci number. dp n signifies the nth Fibonacci number. So if dp of n minus 1 equal -1, that is this. If it is equal to -1, that implies that we haven't actually calculated the n minus first Fibonacci number till now. If it is the case, then I will just calculate the n minus 1 Fibonacci number using fib n minus 1, using the same particular function. Now, and when I have calculated the n minus 1 Fibonacci number, I will just store it in dp n minus 1. So when the next time comes, dp of n minus 1 won't be equal to -1. So in that case, when dp of n minus 1 won't be equal to -1, in that case fib n minus 1 won't be called, and we'll be using dp n minus 1 as it is. So we don't need to go into the recursion of fib n minus 1 again. So by using this approach, we can save a lot of time. Similarly goes for dp of n minus 2. If it is equal to -1, we will just call fib n minus 2. While doing so, we will calculate dp of n as equal to dp of n minus 1 the result of n minus 1 Fibonacci number, the n minus 2 Fibonacci number, and just add them and just store it into dp of n. dp of n equals the nth Fibonacci number, which will be equal to the n minus 1 and n minus 2nd Fibonacci number, and I will just use return dp of n. Now we'll see how this code performs. This code performs the dp code. Fib dp. Yeah, it is compiled. Now I will give the number of test cases, let's say 10. If I give as 5 as the input, the 5th Fibonacci number, it is 5, yes, it's correct. But it will be the 10th Fibonacci number, it is 55. Now let's see what will be the 100th Fibonacci number. In my plain recursive code, it is taking a lot of time. It might take a minute, hour to calculate the 100th Fibonacci number, I don't know, but it is taking a lot of time. Let's see how much time my dp code will take. As you can see, it just took a fraction of time. So this is the power of dp. This is actually the power of dp. It reduced my time from minutes, hours to just fraction of seconds. So that's the power of dynamic programming. Thank you.